get plan for it. So apologies for that. I think we'll get started with where we left off yesterday. Is my screen visible to every one of you? I think recording is started. Mic is on.
It is possible.
Yes, sir. Yes, sir.
All right then. So guys, before we start, again a very quick follow-up question. If you have anything that is causing discomfort from yesterday's lecture, please feel free to let me know that. Uh, because one cause of worry for me is that again in our yesterday's lecture, I think only 5 people were there, and even today, I think only broadly again the same five. Okay, one is a new face. I think broadly again the same set of 5 people broadly are there. Um. So, anyways, I mean whatever it is. So any question you want me to again go back and repeat, or any concept you want me to go back and repeat, we can share the first 10-15 minutes out there before we move on to solving new questions.
Sir, can you revise the for you, like how, what is the structure to follow while solving it?
So when you say the structure, do you want me to make you understand the syntax? So for example, when we started learning for loop, do you want me to explain this structure, or is the question that, or the confusion is that when you write down the solution we understand, okay, this is what how I supposed to write it down, but we on our own, when we start to write, we go blank. So is the first problem the issue, or is the second problem the issue?
Second problem.
Okay, fair. Second problem, all right. So to everyone, one very simple way of how I usually tackle this is I usually write down. So whenever I read a problem, right? Whenever I read a programming problem, I usually write the starting point, that where what all information do I have at hand, what is my end goal, what do I want to reach. So for example, in yesterday's coefficient of skewness question, if you guys don't remember, I'll just quickly scroll to that. Sorry. Right, this question what we solved yesterday towards the very end. So in this question, what do I want to calculate? I want to calculate, let's say my end goal is that I want to calculate coefficient of skewness. My starting point is whatever information I have, right? I have parameter values, etc., whatever it is that we have at hand. Correct? Now, intuitively, right? Forget I am working with R or any other component. Intuitively, I just write down what all steps do I need to require to reach my end goal, right? So the very first step, if you remember, I was talking about is that I need to have a sample at hand. Once I have a sample, I require mu3. Then from the same element, I'll also require mu2, right? Once I have my coefficient of skewness using mu2 and mu3, the next step is, kind of uh, do it for 9 other samples. So once you intuitively break down that entire pipeline into multiple small pieces, then you come to each component and then try to solve that. So have I learned any function in R that helps me generate a sample from gamma distribution? Then you trace it back to programming, right? That yes, okay, there is something called as the R key later what we have studied. Okay, since the distribution is gamma, R gamma is the function. What is mu3? It's the third order central moment. What is the formula of mu3? If you remember, you that expectation formula. I try to write that down in R. Same for mu2. Then I find out the coefficient of skewness. Now if I do it for 9 other more times, one way is I can do it manually, copy paste, copy paste. But is there any other shortcut method which I've learned to repeat activities? Yes, we have learned loops. Uh, is it a fixed number of times that I want to run the loop? Yes, so for loop. Then start constructing the for loop. So all of that for all together to patch in, again, as I mentioned at the beginning, it will take a lot of time because loops are not easy. And in general, solving problems is not easy in programming, right? So it will take a lot of time. But this is how I usually, try to break all of things into pieces and then try to collate them. If I'm confused at all. See if that makes sense. So you will have to try it out multiple number of times before you have that confidence that okay, I'm able to go through it.
Yes.
Others, Bhavani, Ali.
Yes, sir.
Yes, sir.
Okay, great. So let's try this activity one more time. Just to see if you guys are able to, you guys are confident enough to try it out. So I'll give you another question. Mm, yeah, I think this is a good small question to start with. All right, everyone. I'll just paste it in your chat box also. Right. So let's do one thing. Let's solve two questions and then let's quickly move on to while loop and then we'll solve question for while loop as well. Okay, great. So guys, this is one question just like for loop. So before we start, have you guys seen this quantity anywhere? So the line number 280, what I'm highlighting, have you guys seen this quantity anywhere, or have you guys used this quantity anywhere?
Yes, sir.
Where it is,
Yes, sir.
or where have you used it?
It is a chi-square distribution, no? That n
Correct,
square, n minus 1 squared by sigma squared. It is a chi-square with n minus 1 degrees of freedom.
correct. But where have you used this quantity?
For
Normally the
this
tests.
non-parametric test and all we use, I mean,
Non-parametric test.
no, that this is uh, so this goodness of fit and all we use this chi-square distribution. No?
Correct.
Otherwise,
But where have you used this Q quantity? So the distribution is chi-square. That's absolutely right. But have you used this quantity anywhere? Yeah, I think someone else is also trying to tell it.
you mean quartiles and
Yes.
all?
No, no, not quartiles.
Test of hypothesis and the confidence interval.
Yes, absolutely right. You guys have used this quantity in confidence interval or test of hypothesis testing. If you remember the hypothesis, right, that for a single population variance equals some sigma naught. If you remember this hypothesis, one population variance test. This is the test statistic what you guys have used, right? So in that test, you guys just wrote
Testing of
that
variance, single variance, single
yes,
population variance.
yes, single population variance. So in that you have wrote that this quantity follows chi-square n minus 1. Again, we never validated them whether it actually follows chi-square n minus 1 or not, right? Just like CLT, we wrote them in our books. Okay, this holds true. Similarly, when this quantity, we assume that this holds true. So just like CLT, right? How I demonstrated yesterday that okay, actually X bar does follow normal distribution as and when the number of iterations keeps on increasing. Can you guys try and perform the same activity via this example? I have also written down some assumptions below, right? Can you guys take about 5 odd minutes to try and see if you are able to confirm whether the distribution of Q now comes from chi-square n minus 1? Can we do that, everyone? Can we make an attempt?
Yes, sir.
All right, great. Get started. Again, if someone wants to share their screen, guide all of us together, that would be more than I'll be more than happy for that. Else, again, that's also all right. Absolutely. Uh, get started, everyone. I'm here in case you want me to guide you guys. Have any questions? Feel free to ask. Chalo. Take quick 5 minutes. Let's see if you guys are able to get through it. Yeah, Tom, are you done? Are you done with this question?
Sir, I am in mobile traveling. So
Okay.
I'm in mobile
All
only. So I'm not able to. Next time I will put it.
Okay, okay, all
In
right.
mobile only because I'm just seeing it. That's all.
Got it, got it, got it. All right. Okay, so who do we have in the Hansraj? Are you there?
Yes, I'm here.
Yeah.
But I need.
Mhm.
I'm getting home in 10 minutes. Then I will be
Oh,
connecting to my laptop.
okay, okay. All right, all right. No worries. Okay, great. Other people, whoever is working on laptop at the moment, were we able to get, were we able to solve the question?
Sir, doing.
Okay, fair. Thanks, Bhavani.
I'm also doing, sir.
Fair. So do you need another couple of minutes, or you
Yes, sir.
want me to solve?
5 more minutes.
Okay, all right, all right. Okay, just let me know once you guys are done. If you think at any moment in time, okay, that's it. You cannot try it out more. Again, freely, just let me know. I'll start solving for us. I'll keep other questions ready in the meanwhile.
Sir, in this question, N would be the
Mhm.
thousand size of the sample or the.
So this is your size of the sample,
Okay,
and this is the number of times you are repeating it. That is the number of iterations.
okay, okay.
Yeah. So you will take a sample of size 50 from normal distribution with parameters 15,3, and you will repeat this activity thousand number of times.
Sir, in the equation, what is S square?
Can you remember, can you recall what was S square? Or in general, in statistics, when we write S square, what does that mean?
That
Um,
S code is sample variance.
Yes, absolutely right. S square is nothing but your sample variance.
okay.
So in general, usually by default, whenever you see, at least in your theory, whenever you see your S square, it's nothing but denoting the sample variance. Sigma represents the population variance. So this S square is your sample variance. When I say sample variance, I hope you appreciate it is nothing but with the denominator n minus 1 coming from the sample information, obviously. That's why the term sample variance. And this sigma is nothing but your population variance. Last 2 more minutes, guys. At 8:50, we'll start discussing. Yeah, Bhavani.
Sir, I wrote a
Hmm.
program and I got
So you got, I mean, you solved the problem.
yes, sir.
Oh,
Uh,
wow, that's great.
but
Mhm.
I got the answer like everything is like not available and only one value I got. So
That's okay. That's okay. We can just wait a minute. Once
yes,
we are due, we can just share your screen and then we can try to see what exactly have gone wrong.
yes, sir.
Yeah. Okay, great. All right, it's time up, everyone. Um, yeah, Bhavani, can you please share your screen? We can just try and understand what have you done and where exactly we need to go.
Yes, sir.
All right. Before I start, Ria, matlab, should I start discussing, the trick what we discussed initially, that start point, end point, and starting to write down the steps, or was this question comfortable enough for you to, have it very quickly in your mind?
So we can discuss. Like I did a few steps. I didn't get
All
to.
right. Okay. Okay. Fair. Great. So, guys, again, my end goal is very simple. It's always given in the question that I want to confirm the distribution of Q, whether or not it comes from chi-squared n minus 1 or not. So, that is my final end goal. So, if I say that I have solved the problem, my final goal should conclude that yes, Q does follow chi-square n minus 1, or no, chi-square Q do not follow chi-square n minus 1. Right? That's my end goal. My starting point is the information what is given to you guys in that line number 7, 8, and 9. That is what even Bhavani have written it down on line number 10, 11, 12. All right. Now, what is my operation, right? What is the operation that I want to keep on performing to solve this activity? It's very simple. Since I want to understand the distribution of Q, I will first require multiple values of Q. I hope everyone appreciates distribution is made using a lot of or a variety of values. That is the only thing when you see a histogram or a spread coming in, right? You cannot make distribution using one single unique value, right? Then it's obviously not a distribution. I hope that's very clear, right? By the very definition of the term distribution, correct? So, what is required for me to get a distribution of Q? Obviously, first I require a sample. Basis that sample information, I have to calculate the formula that is given to me with respect to Q. Once I have the value of one single Q, again I just have to repeat it n number of times so that I have large set of Qs and I'm good to go. Right? So here Bhavani have done it correctly initially. So she has written it down all the required elements 10, 11, 12, absolutely right. Now I'm not looking at the for loop at the moment. I am just understanding whether she did the operation right or not. Correct. So she took a sample in a variable named D. R norm is absolutely right because R is the key letter to generate a random sample. Norm because it's a normal distribution, obviously. She have taken n as 50. That's the sample size required for you to generate. Great, absolutely right. With parameters 15 comma 3, again that's correct. To calculate sample variance, you use the function VAR in R. So guys, just like mean is used to calculate arithmetic mean, VAR or var in R, that function helps you calculate sample variance. Right? Again, be very careful. You have two types of variances in your books. One is population, that is with the denominator n. One is the sample variance with the denominator n minus 1. Correct? So here var uses the denominator n minus 1 for calculation purposes. Ensure that you remember it. You don't confuse it during the exam. Great. Next, she have calculated the Q quantity. Again, absolutely right. So she's taken n minus 1 into s square divided by sigma square, which is 3. Great. Absolutely right. So the entire program, intuitively what she has written, right from start towards the end line of line number 20, everything is absolutely correct. Obviously, she's getting any because of a very small programmatical issue. Can anyone in the classroom try and understand or debug as to why this issue is happening? So she's done everything right, correct? It's just one small programmatical error what she have made, which is leading to that error. Are you guys able to identify that? Or is anyone in the class is able to identify what exactly is that error?
I in SS that for loop there was a problem.
Correct. There's an issue in the for loop. That's
Yeah, it
right.
is I is equal to 1 to 100 we have to specify, or because I in SSS only he has specified.
Fair enough. That's right. So Bhavani, if you see on line number 14, you have declared I in SS, which is 1000, right? So when I say I in SS, what is the value SS is taking? SS is taking 1000. So I will only take one single unique value of 1000. That is why when you actually try and see all the values, those are NA. And I don't know, maybe if you scroll down, maybe you will see the last value coming as a single
Yes.
number altogether.
Yes.
Because you only substituted the 1000 slot number as a particular value. You never executed the loop 1000 number of times. Hence, the iteration never went to 1000. Again, if you write 1 to length of SS takes one single number of 1000. So it is I in 1 to 1,
Okay.
right? So it will be I in 1 colon SS only, because SS in itself is taking the value of 1000, correct?
So this is fine.
Yes, this is absolutely fine. And now if you run it, it should give you all the required values, right?
Mm.
So now you have a lot of different set of values altogether.
Yes.
Make sense?
Yes.
Great, good attempt. Anyone else in the classroom who wants me to solve this problem out, please feel free to let me know. Ali, Ria,
Yeah, sir, I get a question.
Uh,
Why normal distribution? In the question was chi-square distribution.
because the underlying distribution or the underlying population is normal. If you shift from normal distribution, your quantity Q will no longer follow chi-square.
But the question was, can you confirm that it is follow chi-square distribution, not the normal distribution?
Correct. The question is to prove that it follows chi-square distribution. Absolutely. So we are yet to prove whether Q actually follows chi-square or not. We are not yet done with the question.
Okay.
Yeah. Yeah, Ria.
I'm just checking one thing.
Hmm. Okay. All right. So Ali, were you able to get, whatever Bhavani just showed, or do you want me to solve it together once more as well?
Yeah, let's solve it together.
You want me to solve the question?
Yes, sir.
Okay, fair. Great. Thanks for letting me know. All right. Let's just Open a new script, put down the question. All right, great. Let's get started, everyone. Again, I'll quickly write down the pointers, of how I usually
Can
use.
your screen is not shared.
Oh yeah, thank you so much. My screen is not shared. Okay, here we are back on board, and we go. So for starters, everyone, this is the information what I have at hand, correct? And my end goal is that I want to prove whether Q follows chi-square with n minus 1 degrees of freedom, right? Now, for that, the very first step what I would require is generate a sample from normal, correct? Second step is calculate, you know, Q. For that, I require N, I require sample variance, and I require population variance, right? So I'll require all of these quantities before I can start working with the quantity Q. Once I have Q, obviously calculate or rather repeat step 1 and 2, let's say for n number of times, or let's say Q number of times, or let's say T number of times, correct? So this is how I usually break down an entire problem into some very generic English statement steps. If you see here, not exactly whatever I've written down is program driven, right? So I never wrote generate using XYZ function, calculate using XYZ formula. It's very intuitive to read down in English. Now, when I actually have my steps ready, when I actually have my overall path ready, that how will I reach from start to end goal, now I will come to see what all techniques do I know to solve these problems, right? So can I say starting is just the information that my data set have given to me. So there's nothing difficult for me as such. It's just storing down, the information. So how many iterations do I want to go through it? I want 1,000 iterations. That's what is given in the question. What is the sample size that I want? It is 50, what they have mentioned. What is the distribution? Distribution is normal with mu 15 and sigma is 3, right? All right, this is my given information. Now coming to the operation, generate a sample from normal distribution. So to generate a sample, I have a key letter R. Since the distribution is normal, it will be R norm. If you see my screen and if you see something in the yellowish, lightish yellow popping up, it says the very first argument is the number of sample size. The next argument, that is mean. In normal distribution, mean and the parameter mu coincides. That is, they are exactly the same. Second argument, standard deviation. In your books, you are used to writing x follows normal mu comma sigma square. In R, the second argument or the second parameter is not sigma square, it is sigma. Pay attention that this is a very common confusion point that the student makes. The second argument is sigma and not sigma square. It's the standard deviation and it is not the variance. So I will write n comma mu comma sigma and I'm good to go with my sample altogether. Let's take a variable to save in the sample. So I have my all information stored inside X. Great. Let me just cut paste the formula for Q from here so that I can
Yes, sir.
directly utilize it. Yeah. Yeah.
So are you saying that all the standard deviation is in R, not the sigma square?
Sorry, come again. Are we saying that the standard deviation is?
What R knows is the standard deviation, not the variance. So if we are given the variance, we have to have a square root of it in order to have.
If you're given the variance, you'll have to take a square root of that. Yes, that's right.
Okay. Okay.
That's right. So here in this question, I was already given sigma. Hypothetically, assuming it was sigma square to the power 3, then as we know, right, if I take a square root of sigma square, I reach sigma. So I'll have to take square root of 3, right? So in R, we have a function called as square root or sqrt that, whatever number you give it down, it gives you or returns you back the square root of the same. Or an alternative method is that you just write 4 to the power 0.5. That's what square root is all about, right? So getting the same answer altogether.
Okay.
Okay, great. All right. Guys, continuing back, I have my random variable. I have my quantity Q. So N is something what I've already defined. S square, as I mentioned, is sample variance. You do that using the var function. What is the sample do I want to calculate the sample variance on? The sample information is X divided by sigma square. Sigma is already defined right above here. So I am just taking the square of that part, right? So step 1 done. Step 2 also done. Step 3 is repeat step 1 and step 2 for t number of times. Now here that t is 1000. So either I can, copy paste this code 1000 number of times and work with it. It obviously is too manually cumbersome. That is where we have studied loops. So for I in, how many iterations do I want to perform? 1, 2000. That is where the loop will take, or the I will take 1000 unique values, and the loop will keep on iterating for 1000 number of times. So this is my body. What do I want to repeat? I want to repeat these two block of codes multiple number of times. Now again, if you remember from our past two questions, Q is a univariate or a single quantity at the moment. I want it to say multiple values. So I will have to put an index over here. Since Q will now say multiple values, I will also have to declare it before the loop into a blank loop, or sorry, into a blank vector. Correct. So I have a blank vector. I will be performing an activity 1000 number of times, saving all the values inside Q. Right, guys. Just allow me to change this 50 to 10. There is a reason for that me to do. Right. I am just changing the number of samples points generated from a single loop. I am making it to 10. Right. There's a reason for me to do that. I'll let you know I have done that a little later on. Correct. All right. So are we comfortable till here, everyone? Is this helping us think and write down programmatically?
Yeah, for me, yes, it's clear.
Okay, great. Thank
So
you.
I just had the doubt, like
Huh.
how to identify which is the number of iterations and which is the sample size. I got confused between those. I
Hmm.
took sample size as 1000 and number of iterations as 50 before.
Hmm. Correct. So
How
whenever you see the term size, right, it's always referring to the sample size. So it says 1000 samples, or maybe the way I've written it is also confusing it in a way. So I think I'll maybe write the terminology a little better next time. So when I say 1000 samples, each of size 50, basically I'm saying 1000 packets wherein each packet is of a size 50. Think it of that fashion, or read it in that fashion if you want.
okay, sir. Done.
Right? So 1000 batches where each batch is of 50 data points. That's where it says each of size 50. So usually that's how you read it. Okay, great then. So I'm just running this set of programs. So Bhavani, if you remember, everyone, she kind of wrote the exact same program. So that's absolutely great. All right. Now there are no errors. Obviously, everything is good to go. Now again, my end goal is to prove whether Q follows chi-square n minus one or not. Correct. With this program, what I've written on the board, am I commenting, or am I solving, or am I reaching my end goal at the moment? Or have I reached my end goal at the moment?
No, sir.
No,
No, sir.
obviously not. So can you guys guide me? How do I do that?
No, we have to find that chi-squared, calculate the chi-squared, and then we have to compare the tabular value.
Okay. All right. Fair. Others?
we can test whether Q follows chi-square system.
Correct. But how do I validate that?
Sir,
Mm-hmm.
in R, if I'm not wrong, we have the chi-square distributions graph. So we plot what we got and the chi-squares graph and check that. Will that
Right.
work?
Yes, absolutely. That would work. That's a good one. So, guys, again, to see the distribution, again, Q is a continuous quantity. So, you are required to calculate a histogram to understand the distribution of Q. Now, obviously, by the definition, we know chi-square is a positively skewed distribution. And when I plot histogram of Q, I also see something which is a positively skewed distribution, right? Now, not necessarily that all positively skewed distribution are chi-square distribution only. It can be some other distribution that is not chi-square as well. So now the question is, how exactly do I get my comfort that this distribution is nothing but chi-square n minus 1? So one way is what Bhavani absolutely correctly mentioned, is that can I say this distribution, or rather I'm asking a question to all of you guys, can I say that this distribution what I've got over here is nothing but kind of an empirical distribution, or the distribution that is made out of sample information?
Yes, yes, it looks
Yes, sir.
like a positive skewed distribution.
Correct. Moreover, it's a distribution that have been generated using sample information, right?
Yes,
Now,
yes.
when I say theoretically that my x follows chi-square n minus 1, can I say theoretically I have some f of x in a mathematical value for that? So theoretically, when I say x
Yes,
follows
yes.
normal distribution, so I know densities of normal distributions can be written by 1 upon square root of 2 pi sigma square into e to the power some, all of that entire quantity, right? Similarly, I also have an f of x for chi-square distribution, correct? So whenever in R, you have to calculate theoretical densities. I'll repeat, whenever in R, you want to calculate theoretical densities of normal, chi-square, gamma, you use the key letter D. D stands for densities, right? We have already studied the key letter R to generate random sample. Now we learn another key letter, that is D, used to calculate densities. So D gamma is to calculate theoretical f of x for gamma distribution. DEXP is for exponential distribution. D norm is obviously for normal distribution. And since we are working with chi-square at the moment, we have D chi-square to work with the densities of chi-square distribution. Good to go, everyone. So what Bhavani was trying to tell over here is that, can I say this is nothing but my histogram? Now I will also have a density or a theoretical f of x for chi-square n minus 1. Yes or no?
Yes.
Yes.
So what she was trying to tell is that if you have a histogram, just hypothetically drawing something, right? So this is nothing but what you got from your simulation. If hypothetically chi-square n minus 1 also follows a similar trend or a similar density curve, then can I say the histogram and my chi-square distribution kinds of overlap?
Yes, a
Yes.
frequency curve like.
Correct. So if they overlap, then I can say that the distribution, what my histogram or what my Q follows, is nothing but chi-square n minus 1. However, if the distribution of my chi-square n minus 1, let's say, looks something like this. So obviously now the orange line and the histogram, the two guys are showing two different pictures altogether. Correct? In that case, you say that Q does not follow chi-square n minus 1. So this is what we'll have to try to plot to understand whether the distribution what my histogram is trying to tell, and whether the distribution my theoretical f of x is trying to tell, whether they overlap each other or not. If they do overlap, I am good to go. Otherwise, there's a problem with me in terms of the quantity Q. Is this making sense, everyone?
Yes, but we can use goodness of it also.
Uh, yeah, you can use goodness of it, but right now we only want to prove it graphically. You are right. You can use goodness of it when we reach unit 3, right? That is the time when we start to study goodness of fit test and all of the different forms and shapes. Okay, great.
Sir,
Yeah, yeah.
sir, a standard definition of what I learn in my classes is that chi square follow standard normal square.
Mm-hmm.
Uh,
Chi-square
by that
follows.
can
Okay, I get the what I'm trying to tell. Okay, correct.
so by using that can we plot the graph and see directly what they follow.
See,
Means
so
mm,
Bhavani, so when I take a square of a standard normal variate, right? You are right that the distribution follows chi-square, but then that is chi-square with 1 degrees of freedom. That is chi-square. That is not chi-square with n minus 1 degrees of freedom.
okay.
I hope you recall that.
Yes, I will.
Sorry.
I will try to recall, but
Yeah, no,
I will get
that's
confused.
absolutely fine if you don't recall. I'm just trying to highlight that. So if a standard normal quantity, when you square it, you are absolutely right. It starts to follow chi-square, but then that's only with 1 degree of freedom. Here we're trying to work with n minus 1, and n minus 1 is definitely not 1. Hence, that approach is something what we're trying to avoid. But that's a good one. It's great to see that you remember that property. So
But if we write sigma x say it's a squared, no, it's n degrees of freedom. Square of the sum of the squares of standard normal distribution with
yeah, but then instead of that, I would rather directly go towards chi-square, right? Then, so
yeah,
if
correct,
my n
correct,
is
correct.
30, then I'll have to add 30 quantities now, uh, which would maybe confuse us as to what exactly are we trying to do here. So just to avoid that confusion, it's better that we directly start using the chi-square distribution directly instead of taking another distribution and then trying to reach chi-square first, then try to use that distribution to compare it with Q. So just to cut down that journey altogether.
Sir, I am Anushka. I don't know why
Sorry.
you are saying my name is Anushka.
Oh, I'm so sorry. I'm so sorry. I think you were not there at the start of the lecture, right? You just joined in, if I'm not wrong.
Yes, right.
That's why. So I only remember 5 students. So I thought only those 5 are there. I'm so sorry. Anushka will
No,
come out of the screen and hit me. I think if I call her once, if I call her name as Bhavani much. I'm really sorry for that.
it's okay, sir.
Yeah. Thank you for forgiving. Great, everyone. All right. So is the
So now we
method.
have to superimpose this histogram with this
Yes,
theoretical distribution.
yes, absolutely right. Now I will try to superimpose the theoretical density line on top of the histogram. Great. So guys, let's do it together. I mean, pay attention on the screen. Don't type with me. All right. So to superimpose, right? Write it down somewhere or remember it that whenever I say I want to superimpose something, we have a function called as lines in R. Correct. Lines is the function that helps me superimpose anything on the respective or on the current chart. Great. So lines works just like plot function, what we did yesterday, if you remember. We learned plot function yesterday when we were doing the MLE question. Lines works just like plot. You have to pass in two information, x-axis information, y-axis information. That's it. And by the very definition, it says lines, right? So it will create a smooth line chart for the respective x and y coordinates you give it to, right? Now tell me, if I want to superimpose the density function for chi-square n minus 1, what will be my x? What will be my y? whenever I want to work with, or whenever I see the distribution, or whenever I visualize the distribution of any particular statistical
X is
distribution,
the sample value, and
X is the
chi-square,
sample value, okay.
and then Fx, that Y is Fx.
Y is fx, good, absolutely right. So y is nothing but my f of x, correct? That here we will calculate using d chi-square, and obviously my x information, or my x axis is nothing but my x information. But I will not take my sample values over here because sample and theoretical values can differ in terms of x. So what do I mean by that is, if you see on the right hand side of the tail over here, uh, maybe some values theoretically were possible at a higher frequency, but empirically it have not, right? So I will not use q to generate f of x. I will have to generate an x of my own, or a x of my own, to plot or to create densities. Is that making sense, guys? So what Tom is maybe saying, that you can use q to plot on your x and use the same q information to plot or to calculate densities as well. I'm saying I'll not use q. You will have to generate a x of your own, right? Now the question is, how would you generate x of your own? What all values of x should I take, rather, for that matter?
Should be frequency distribution we have to do, or no?
Okay, no, no, grouping is not required. Other, okay, fair. Can anyone quickly tell me what all values of x should I take? So I'm plotting a theoretical density now, right? So whenever I plot normal distribution, I write it down or draw it very confidently. This is normal distribution, hypothetically, let's say. So obviously, there might be some range where this x-axis goes to, right? So what should be the range in this example?
Chi-square is positive, so all values greater than 0.
Fair, all values greater than 0, but then the range of chi-square is also 0 to infinity. So should I go towards infinity? Because infinity is, kind of...
No, maximum value of x we have to take for the instead of infinity. Maximum
Yeah,
value
but
of x
then
we have
the
to take.
theoretical, yeah, absolutely, absolutely right. But then the theoretical information says that x is greater than 0, which means that max of x is infinity.
From the sample, we had to take maximum of x, sample size also.
Okay, fair, fair. That's one right answer. I think someone has something in the text. Sample size. No, Ria, sample size is not the answer, because sample size and the length of the distribution, they are not dependent kind of way. But what Tom said is absolutely right. Since I want to superimpose my density on this histogram, if I see the distribution or the range of this histogram, it goes from 0 to 35 approximately, right? So I will create x that goes from 0 to 35, right? Now, obviously, chi-square is a continuous distribution. When I write 0 colon 35, I am making 0, 1, 2, 3, 4. It's a discrete jump. So how can I make this jump to continuous from discrete? How do I ensure that the jumps I take are kind of continuous, are comparatively smaller, instead of taking discrete 0, 1, 2, 3, 4?
Sequence function.
Yes, absolutely right. You can use the sequence function for that. So now you can jump from 0 to 35, let's say at a step of 0.01. I hope you appreciate this jump is quite a smaller jump as compared to 1 now, hence making your x size a lot more continuous, making it more compatible with your chi-square distribution.
So why did we take 35?
35 because the range of my histogram, the x-axis range of my histogram is 0 to 35. So if at all it was 0 to 500, you would have taken it 0 to 500. So you would decide it using or looking at the histogram currently on the screen, because this is the chart on which I want to superimpose my line. So even if I make it 500 hypothetically, for example, is my histogram going till 500? No. So technically it doesn't make sense for me to go to 500 because my line, what I will be seeing on the screen, is only up to 35. So even if you want to keep it 40, that's comparatively fine. If you want to keep it 35, that's absolutely fine. So you decide the range of the theoretical densities using or looking at the axis of the currently made histogram. See if that makes sense.
Sir, for my histogram, like I have the values till
Do you
30.
have a different range? Yes, if you have that concern, that's absolutely right. Because if you remember, I changed my n to 10. If you are still at 50, you might see something which is a little more symmetric in nature curve, and obviously you will see a very different scale of axis.
So should I follow my range, which is in the
Yes,
histogram?
yes, yes. Since your n is different, you will follow the range what your histogram is asking you to do. So if it's saying from 20 to 100 hypothetically, then you will select 20 to 30, 20 to 100.
It is showing 20 to 80. So should I go
That's
from
completely fine.
20
Yes,
to 80 and 0.01?
yes, absolutely, absolutely right. Yes, that's right. Yeah. Anyone? I think someone else was also trying to speak in the meanwhile.
No, sir, I told I understood.
Okay, okay. All right. All right, great. So guys, now quickly I'll just also feed in. So I have my x-axis. To calculate densities, I require two things. If I just write d chi-square, and if you see here, the very first argument you require is the xi information. That is those sequences what I've generated. And the second is the degrees of freedom of the distribution. So I will exactly paste the sequence function again. So x-axis is good to go. In d chi-square, the xi information is again good to go. The degrees of freedom is n minus 1, as we know, right? I will just give this line a red color so that we can clearly identify the theoretical densities on my screen. Make sense? I will also increase the thickness of the line. Correct. So I hope everyone remembers thickness of the line. So just for more information, a very simple thing. So this line versus this line what I have drawn. I hope everyone appreciates the second line is a lot more thicker, right? So LWD, that stands for line width, controls the thickness of the line. By default, it is always 1. If you want to increase the thickness or the boldness of the line, just like I did it over here, then you increase LWD. So I'm increasing it to 2. Why exactly 2? It is just a cosmetical change for you to clearly appreciate the theoretical line. Even if you don't write, that's absolutely fine. Even if you write, that's absolutely fine. It's just a cosmetical change at the end of the day, right? Can I run the lines function, everyone?
So,
Is this making sense? Yeah.
just one question. In the d chi-square, why are we taking the x values the same as the x values did we take in the...
Okay. Fair, fair. That's a good question. So whenever I have a 2D chart, I have x and y information, right? Here I have x and f of x, correct? So when I create a density curve, right? What exactly I am trying to plot is x and f of x, right? So when I draw a curve, this f of x corresponds to this xi information, right?
Yes.
Basically, what I'm trying to say is that you have one x, you substitute that inside f of x, and you get an answer, right? So this x and this x should be exactly the same. I cannot change that. I cannot say that this is something what I've inputted as x1, but what goes inside calculation is x2. That would be very incorrect, right? So I want the f of x that is corresponding to that same x. Hence, this is my x-axis and this is my y-axis. So you will always input the same x size what you are plotting it on your x-axis. It is only then you will have the corresponding f of x. I hope you appreciate that.
Yes, sir.
Right? Great. So everyone pay attention to my histogram. I will now run the lines function. Right? Great. No error on the lines function, successfully executed. Any change you see in my histogram?
Yes, the red line
Yes,
can be seen.
absolutely right. Now I also see something which is a red line over here. So is the red line overlapping the histogram?
No.
No, obviously no. My peak looks very different. My tail looks very different. And the line what you have made on the screen looks very different. So what is the conclusion? Do I conclude that Q does not follow chi-square n minus 1? Because
Yes.
if it were, it should have been kind of overlapping with its peak and trough, which I don't see at the moment. Guys, what is
Yes,
your
that's
view?
true.
What is your inference? Yeah, sorry, I couldn't hear you.
I said that's true. It doesn't
That's
follow
that's
Pascal.
true. Okay. All right. Fair. That's a fair interpretation. Others? Yeah, others. Anushka, then Riya,
All
Bhavani.
this have the same height, All this is that red one, no?
Mhm.
That red, but where is that that line that superimposed one?
This is that line. The red line is what we have superimposed.
That means all have the same. It is like a rectangular distribution or what?
Um, Not really. Not really. So one thing is that maybe the values. Okay, if I say that, that will be the answer basically. Yeah, kind of. Not exactly, but so if I answer your question, that will technically be the answer to the question what I'm trying to figure out it from you guys actually. Okay, fair. So guys, on my histogram, what is my y-axis? It's the
Frequency.
frequencies. When I plot densities, right, or when I used the line function, I'm plotting densities. Are frequency and density is the exact same thing?
Frequency and density. Frequency, density, and no. Frequency means we have to that we have to group this data into 0, 5, 5, 10, and all these things. Or we have to divide the fy that all each frequency by the total number. No, total these things.
Fair. That's right. Fair enough. So guys, here
Fy
what
by
we were
di,
trying
fy
to
by di, like that.
correct. Fair. So guys, here what we're trying to compare is frequency to densities. Both of these information is not apple to apple, right? It's like comparing kgs with grams, right? The unit in itself is not same, right? So I will have to very firstly convert my y-axis of the histogram to densities, right? It's only then when I can compare the two lines equivalently. So to ensure that my histogram is made on densities and not frequencies, I have an argument called as freq equal to in R. By default, obviously it is true at the moment. That is the whole reason you see frequencies on your y-axis. The moment I switch it to false and I run the program again, you will now see everything being changed to densities. If you appreciate the chart or the shape of the chart never changed, it is exactly the same. It's only the y-axis that is now being rescaled towards densities.
That is total Fi divided by total number, total
Yeah,
Di.
broadly, yeah, fair. Crudely, you
So that
can say
the area of the entire
is
histogram will
one.
be one.
One. Absolute. So that the entire area under the histogram will becomes one. Absolutely, yes. Is this clear, everyone? Is this making sense for us?
Yes, sir.
Great, thank you. Now if I run the lines function again,
That
right?
is good. That is good.
Yeah. So now if you see, basically my line was at such a bottom that I could not see this peak enough because my frequencies were in 400, 500. But obviously when you rescale both the axes appropriately, I hope you appreciate now you are able to see that exact curve altogether.
So the frequency equals to f. What does that f means? Like it is
So
a
frequency, so R is basically asking you, do you want to keep frequencies on your y-axis? So if you remember, whenever I have to communicate yes or no to a programming language, I do it via true and false in terms of the Boolean values. So I want to say no, I don't want frequencies. Since my answer is no, I have to communicate in terms of false. Hence the term freq equals f.
so how we know that we don't want the frequencies?
Because on the lines function or within the lines function, you are using densities. Densities, if you remember or if you see, are very much in decimals, very small numbers. Frequencies, by the definition, if I have 1000 data points, frequencies will easily go in discrete points at 10, 50, 100, 200 altogether. So to ensure that both of these charts are speaking the same unit, right? That is, they're speaking about the same measure. That is why you will have to set it to densities. So the rule is very simple. Whenever you want to superimpose densities on a histogram, you will set the frequency to false. If you just want to see the distribution, right, whether it is positively skewed, negatively skewed, symmetric, then I don't really care whether it is switched to densities or it is switched to frequencies, because my only objective is to see the distribution. The shape doesn't change irrespective. So in those situations, it doesn't matter whether I switch to frequency or whether I switch to densities. See if that makes sense.
Yes, sir. Got it.
Got it? Any issue you see on the chart, guys? I see one issue because no one is highlighting it. So probably I'll have to say. So okay, getting
Top
back to
end
this.
is tapped off, no? Top
Yeah,
is the highest is bit because
correct.
it's tap off.
Correct. Absolutely right. If you see the peak of the red line, it's kind of being not shown very smoothly because the chart is kind of cutting it off, right? So how do I ensure that I resize my chart? I will have to resize my histogram for that. How do I do that? We have an argument called as ylim, standing for limits of the y-axis. Limits for the y-axis. What do I, or what range do I want my y-axis to be? So I want my y-axis to start at 0, hence 0. I want my y-axis to, let's say, go all the way up to point 1, which is at the moment, let's say, 0.08. So comma 0.1. Since these are two numbers, I always supply more than a number inside a vector, hence something like this, and closing of the bracket. Now if I run it, histogram is again back to good to go. And now when I run the same program again, you see there's still some form of cutting up of the chart, but broadly you're able to see the trend.
If you give point 1 2,
If I make it
then it will
point
be.
0.11 or 0.12 fair, now I think that's when you'll be able to clearly see the line. Yeah, altogether.
So, but for my chart, it's showing a normal curve.
Yes, sir.
Yes. Yes, absolutely right. That is the whole reason I shifted that 50 to 10. So whoever worked upon the program with n equals 50 as the n, right? If you remember, n over here is nothing but the degrees of freedom of chi-square distribution. As n tend towards infinity, chi-square shifts from positive skewness to symmetric. That was the whole perspective of when I was running the program. I told you guys I'm shifting this number from 50 to 10 so that I could show you a positively skewed chart. If I make it 50, I myself will get a symmetric curve because n in such a scenario, the degrees of freedom in such a scenario is quite large for it to move from positive to symmetric. See if that explanation is making sense now.
As n tends to as n becomes larger, this chi-square also tends to normal, right?
Hmm. Fair,
But
fair.
also, but also it in the positive side only. But actually in normal distributions, negatives and positives are there, na? But in chi-square, it's only positive values are there. So we
Correct,
have a positive normal distribution only.
correct. Fair, fair enough, fair enough. So what he's trying to say by positive distribution is that he's saying x, the random variable x, would kind of take only the positive values. It will not go towards the negative side. So for example, if I write x follows normal distribution with mean 50,000 and standard deviation as 5, for example, right? Or 1, for example, then what he's saying that by the definition of normal, we know normal can take any values between negative infinity to positive infinity, correct? But if I have such a distribution, then my x would not take any negative values because my distribution is whole and sole concentrated on the positive side of the axis, that is beyond zero. Hence, even though the theoretical range says negative infinity to positive infinity, your x would never take negative values or would never go below zero, right? In fact, would not even touch zero in this scenario what we have taken. So that is what Tom is trying to tell when he's trying to say positive distribution. I hope that that makes sense, everyone.
Yes, sir.
Yes, sir.
Great, guys. So do you want to write this that down, write this thing down, or can we move on to the
Yes, sir.
next? Okay, you want to write this down?
Yes.
Okay, fair, fair. No worries. Take your time, guys. If there's anything you want me to repeat, please feel free to let me know. Okay, I'll just zoom out a little so that yeah, you can see the entire program in one snapshot. Someone who's done, please give me 5 seconds to move away from my screen. Someone who's done with this question, I have obviously a lot of questions for you guys. Someone who's done, please quickly, or rather, I'll just put this question inside the chat box. You guys can obviously start with this question. Someone who needs time for this question to settle in, no problem. Take your time to settle down. Let me know, once you guys are done, we can move forward.
Yeah, sir. Can you zoom out?
Yeah, I'll zoom out. Thank you. Thank you. Thank you for letting me know.
Sir, so for this question, do we need to calculate alpha and lambda separately from the mean and variance?
The question which is shared on the chat box right now.
Yes, sir. Yes, sir.
No, no. You are expected to. If it was the question on mode, right?
Yeah, but the
Yeah.
mean and variance is given. Alpha and lambda is not given.
Acha, in that sense, I'm so sorry, I misread your question. Yes, absolutely. So the very first step, what you will have to do is to use method of moments and get back to alpha lambda.
Oh,
That's absolutely right. So R will not do it for you. You have to do it manually and feed in those values.
okay, sir.
Yeah. So great. That's a good observation that you don't have parameters given to you. You have mean and variance. And for gamma distribution, mean and variance is not equal to alpha and lambda. That's a good observation.
Sir, we can calculate the mean and variance, the sample, and then we have to equate with using respective method of moments, and then we can find alpha and beta, not manually. In program itself, we can calculate.
No, no. So in program, obviously, if you give that final equation that alpha is equal to some quantity, lambda is equal to some quantity, then R will calculate it for you. R doesn't understand method of moments, so it will not directly calculate
So
it.
we have to write a program for that alpha by beta is equal to this thing, alpha by beta squared is equal
And
to.
then it is as technically, if you see, it's not a program, right? It's just a equation what you have yourself reframed and give it to R. A program will be something where I give that there are two equations, two unknowns, and solve it simultaneously to give me the two parameter values. That would technically, be a automated program to get unknown parameters. But here you're technically changing the equation and trying to write alpha is equal to something, beta is equal to something. So that's already the hard work or the grind work is done by you, not R actually. The automated function would be in a fashion where you say, something like this. So you're saying 50 hypothetically is equals to alpha by lambda. You're saying 100 equals alpha by lambda square, right? If you give this information, now I have two equations, two unknowns. Now if R automatically calculates both of them and gives you alpha and lambda, right? Then that kind of becomes an automated program. If you yourself only write alpha equals hypothetically again 50 by 100 in some shape or the other form, then kind of you have done the hard work. It's not the R who have done the hard work. It's just calculating the mathematics, which ideally a calculator can also do that. So this one, would be kind of an automated program where I give in two equations, three equations, and then it will try to solve, for all of them, solving them simultaneously. I hope that makes sense.
So can we solve for alpha and lambda and just put in the values directly in our?
Yes, that's what absolutely right. That is what you're expected to do. Manually calculate alpha lambda using method of moments. Put that directly to R.
Okay, sir.
Yeah. Ali, are we done with this question, or you still require some
Yes, sir.
time?
Yes, sir. Yes.
Yes, for which one? You still require time, or you're done with the question?
No, it's done.
It's done. Okay, great.
Okay.
Thank you. All right. So guys, can we take a quick short break before we move on to the next question?
Yes, sir.
All right, great. Let's keep a quick 10 minutes break. It's 48. Let's connect back at 58 then. Good to go, everyone?
Yes, sir.
Yes, sir.
Hello. Great. See you guys at
Yes, sir.
58. Okay, bye. All right, it's 58, everyone. Let's get back. We'll just wait for a minute, just to wait for someone who's just about to catch up. Yeah, so in the meanwhile, Ria, what you have shared, it's a good attempt. So the mode function, what you have used, right?
Yes, sir.
It's not used, or rather, it's not to calculate the statistical mode in R. It stands for something different. So while the mean function stands for arithmetic mean, while the median function stands for statistical median, mode does not represents the mode what we are talking about. So that line of code will need to be redefined. Rest, I think what you have written is a fair attempt. Trying to put it in the loop, generate the operation, and then calculate mode. It's just how you calculate mode is something what we will learn in this question. So the highlight of this question is actually how do you calculate mode from empirical information. Is what we will learn.
Should we use that formula that we have for mode?
Uh, no, that becomes your theoretical answer, not an empirical answer.
Okay.
Okay, great guys. Overall, it's a fair attempt. That's a good one. Great. So guys, for the remaining part, let's try to take one more question. Uh, and then we will learn something about a concept called as seed, and then we can close for the day. So if we have more time left, obviously we can take more questions, not a problem. uh I'll just give you about 10 seconds to quickly read through this question in case someone missed reading it, due to some any other reason. 600 gamma distribution, store the empirical mode and comment on the values. Okay. Right. Yeah, Bhavani.
Sir, are we discussing this question's answer or are we moving?
We are discussing the question answer.
Okay.
This was the question what I gave you guys, right?
Yes, sir. Yes.
Yeah, we are discussing this right now.
Because I am stuck after a particular line, so that's why.
No worries. We will solve this question. Don't worry. Everyone good to go reading the question? Yes, no.
Yes, sir.
Great. So I'll let you guys find out alpha and lambda. Can you guys quickly tell me what were the values of alpha and lambda? I think that was pretty simple using MOM. So it will be 50 equals alpha by lambda, 100 equals alpha by lambda square. Two equations, solve them simultaneously and get the answers.
25.
Sorry,
25.
alpha is
25.
25. Okay, all right. And lambda is
Half.
half. Okay,
Oh.
fair. Thank you. Great. Now, guys, in this question, we will learn something called as how do you calculate empirical mode, right? Now, before we start calculating empirical mode, what is it that you understand when you hear the term empirical?
What's the question, sir?
Yeah. So in this question, we are trying to learn how do you calculate empirical mode. My question to you guys is when I say the term empirical, what is it that you understand by the term empirical?
From the experiments, from the sample. From the sample, we have to know what is the mode.
Fair. Absolutely right. Now, guys, there are two types of information what you have available, right? One is the theoretical information, right? When I say theoretical, it's nothing but the mathematical information what you have written down, correct? So when I say density of normal distribution, and if you say 1 upon square root of 2 pi sigma square, that entire term, that is nothing but the mathematical driven equation. Hence, it becomes nothing but the theoretical densities, right? Similarly, another type of information what you have at hand is called as the empirical information, right? Empirical information is any information that is derived using the sample information at hand, right? I'll give you one very simple example. If I have an unbiased coin, or if I have an unbiased coin, and if I toss the coin 10 times, correct? Theoretically, how many heads and how many tails would you expect to observe?
Theoretically, 5 heads and 5
Correct.
tails.
Absolutely right. Theoretically, you would expect 5 tails and 5 head because you see it's a 50-50 probability, right? However, in reality, when you actually go and perform the experiment, if you actually go and toss the coin 10 times, you may not see things being exactly 50-50, right? You may see 6 heads, 4 tails, or 4 heads, 6 tails, 7, 3, all of those possible combinations, right? So that information, what you derived from the experiment, from the sample information what you have collected, any information or any insight from that sample is something what you call it as empirical, right? Now, obviously, if you calculate mode using that information, hence the term empirical mode. See if that is making sense, everyone.
Yeah, for me, yes.
Okay, great. Others, are you good to go with what is theoretical, what is empirical?
Empirical means from the experiments, and theoretical means from the
Yes.
theory.
So empirical means from the experiments or from the sample information at hand. So here we are not exactly doing any experiment. Hence, I'm using the term sample information. So whatever data we are generating, whatever samples we are generating, it's basically using that. Any information using that sample is nothing but the empirical information. Mathematically, whatever you have derived in the class, in your lectures, are nothing but the theoretical information. Any questions, guys?
Clear, sir.
Great. All right. So now let's say if I just copy paste the question, let's say to a different script. So now guys, if I let's say generate a random sample from gamma distribution, I'm just hypothetically taking any values altogether. I think it was 25 and 0.5. All right. R gamma. Okay. So now if I ask you guys, how do I see the distribution of X? How would you answer it? I have a random sample, and now I'm saying you guys, I want to see the distribution of X. What measures or what functions would you use to see the
D,
distribution of X?
D, D
Next,
gamma.
D gamma is for you to visualize the theoretical distribution of gamma. I want to visualize the distribution that is sitting within X, that is the empirical distribution. How would you view the empirical distribution or the distribution collected in your sample variable, everyone?
Histogram.
Absolutely. Great. Very good. Using histogram. Right? Everyone
Yes.
making sense? Using histogram is the answer. Absolutely right. Now, is histogram densities or is histogram a density curve?
No, we have to put the lines, then he superimpose.
Yes, absolutely right. That's good. So, on the histogram, if I kind of, you know, make the line connecting the bars something like this, can I say the red line is nothing but the density curve of the empirical information sitting within X?
Yes,
I'll
yes.
repeat. Can I say the red curve what I just drew is nothing but the empirical density basis the sample information sitting within X? See
Yes,
if
frequency
all
curve.
of,
Frequency curve.
yeah, fair. Thank you. Thank you, Tom. What about others? Are you guys able to appreciate that statement?
From the midpoints of this histogram, we are drawing a curve.
Fair,
So that's
fair,
a frequency
fair
curve,
enough.
like.
Fair. Yeah, that's a frequency curve or density curve. Fair, fair enough. Others, do you appreciate with me making the statement?
Yes, sir.
Right? Now, this red line, what I just drew, was it using any theoretical formula or f of x? Or was it purely using the sample information, what I could see using the histogram?
From
Only
sample
sample
information.
information.
Yes, absolutely. That was only using the sample information at hand. Hence, this curve, what I've made, right, is the empirical density curve and not the theoretical density curve. Are we good to go on this part, everyone?
Sir,
Yes, sir.
Yeah.
like, is this the curve that we drew using the chi-square or the thing that we drew with the data only?
This curve is with using the data only.
Okay.
So for me to generate this red curve, I have used absolutely zero information, whether my x is gamma, normal, chi-square, anything. Absolutely zero intel on what the distribution is. This curve, what I've created, I hope you remember, I have just kind of made a line on top of the histogram. It was a freehand curve.
No, you have drawn freehand curve only, no? Not
Yeah,
using lines and all.
that's
No superimposition.
yeah, correct. That's what I said, right?
Yes.
There is absolutely no reliance on the distribution. It's a purely freehand curve. By the definition of what I mean by pure freehand curve is that it's an empirically driven information. Whatever I see within the sample is what I'm trying to use. I am not at all referring to any mathematical f of x formulas.
Okay, sir. Got it.
Tom, is it good to go?
Yeah. Because for the other one, we had to use lines command, for superimposition.
Correct. That's a different question. I think we are way past that question. This is a completely new problem statement we're trying to solve now. That question is gone.
Understood.
That part is over now. All right. Now, guys, if this is very clear, right? For me to generate this red line, now obviously I have just made it a freehand curve. Obviously, everyone will have a different line altogether then because everyone's freehand will be very different. So, to ensure that I can get a empirical density curve using some techniques, right? We have something called as a kernel density, right? Okay, yeah. So you can clearly see it. The density function, if you see, right, it says kernel density estimation. So kernel density function helps you generate this red line, right? Again, if you remember, this red line is completely independent of any distribution name. It doesn't matter what the distribution is. The red line will purely be calculated using the sample information at hand. Hence, what I'm trying to say over here is kernel densities helps you generate empirical densities, right? Without me explicitly knowing what the theoretical formula of f of x is. Just like I drew the red line over here. Obviously, what kernel
Sorry,
density
sir,
will create is
instead
a
of
lot more mathematical one.
you using that freehand curve, you use the command kernel density, right?
Yeah, instead of using the freehand curve, kernel density will now dictate me as to what that red line will be. Obviously, it's more of a mathematical structure what the kernel density uses. So there is no subjectivity between you and me because our freehand curves may vary. Kernel density obviously will give us the same or the exact same empirical density curve. Is that good to go?
That means it's a command, like kernel density is a command
It's a
source.
function. It's a function. Yes, it's a
It's a
function.
function to avoid subjectivity, correct?
Yes, absolutely. To avoid subjectivity and calculate empirical densities. Others, are we good to go with this one?
Yes, sir.
Yes, sir.
Great. So I will just quickly demonstrate you guys something over here. I'll just zoom out a little. So everyone appreciates I'm generating a random sample from normal distribution. Let's say I generate about 1,000 points. If I don't write any parameters of normal distribution, by default, it takes standard normal. That is mean 0, variance 1, right? So as we learned, kernel densities is what helps me create empirical densities. The function to create kernel density or generate empirical densities or kernel densities is the density function in R. How do we use this function? It's very simple. You give the random variable x between within it, and everything else will be calculated by R. Okay, no errors. Now, if I just plot KD, that is the kernel densities, you see you have a quite a smooth line over here, right? Is this symmetric or a exact bell-shaped curve?
Exactly bell
No.
shape. It's slightly skewed to the right, but it is
Fair.
all purpose. It is okay. Like
Yeah, fair. So theoretically, in classroom, how we used to draw a normal distribution, it clearly doesn't look that way, right? That is because this is not the theoretical distribution. This is the empirical distribution. This is nothing but the distribution what your sample information when you actually go to the population and collect is what is showing you the picture like. Make sense, everyone?
here
Good to
we
go.
completely that
Yes, sir.
histogram is completely disappeared, and only this freehand this
Yeah,
thing is coming.
yes, absolutely right. Here it's kind of I have made the histogram invisible and only the red line remains. That's what you call densities, right? Whenever you draw a normal curve, you don't have histograms. You only have the smooth density line. That's what we have drawn over here, right? On top of this, let's say if I
Sir, if
just
you sir, if you write instead of normal 10,000, it will be 10,000. It will be like
yes,
it will be
yes,
symmetric. Like.
yes, absolutely right. If I make it 10,000 instead of 1,000, more data points means I will be more closely replicating the theoretical distribution. So right now, when I just hold on. So right now, when I plot things, if you see the red curve is the theoretical curve, and the black curve, which is a little moving crooked here and there, is the empirical curve. Let's say if I make it 100 instead of 1,000, then again less data points, which means that I would be deviating a lot more from the population. You see, this clearly looks very weird. Versus, let's say if I make it 10,000 now, then I am kind of replicating the population. Obviously, if you see the peak, again a little more discrepancy here, but then that's fine because you are working with a sample at the end of the day. You may see some things here and there that will not exactly overlap the population because obviously it's a sample. That's a very clear definition of that. Good to go, everyone. So one red line is your theoretical information, and the black line is the information that your sample has given you. That is the empirical information. Good to go.
Yes, sir.
Others?
Yes, sir.
Okay, great.
Can you please let me see the formula? Yes, thank you.
Formula for what?
The red one, like.
Okay, okay, all right. I'll just pause here for a second, in case you
Thank
want to, we're trying to figure out something.
Yes.
Okay, great. So guys, now since we require, coming back to our question, this is where it all started, right? And this is what we want to solve for today. So the whole reason we studied kernel densities or the concept of empirical densities is so that we can solve this question, right? So without even further saying, obviously we will use the density function what we have studied now inside this question. right? Great. Now, can anyone tell me what is the empirical mode in the
I think
chart what you see on the
I
screen at the
think
moment?
that is the maximum point. The zero is a mode.
Okay, but do you see my peak? Is this the peak of my empirical curve? If you say zero, then ideally this is the where the peak has to be.
Yeah.
But the black curve is kind of peaking it over here, right?
Black is slightly minus 0.01 or something.
Correct, fair. So it is slightly on the negative part. Again, that is fine because it's an empirical information. Your empirical and theoretical will not exactly coincide. Obviously, they are expected to be nearby. So if I say 0 point, let's say 0.1, that is still approximately closer to zero, acceptable, not a problem, right? So can anyone tell me, guys, what is the mode here? Is it the density 0.4 approximately, let's say, or is it the answer zero approximately, let's say? What
Zero
exactly is it?
approximately because it is the x only. The frequency is a maximum, so it will be zero, nearby zero only the mode.
Okay, fair. Others, everyone agree to this statement? Is zero my mode or is 0.4 my mode?
Zero, zero is our mode.
Yes,
Yeah, zero.
absolutely right. Zero is our mode. Now, how did you declare zero to be the mode? The
It's the
very
maximum
first step.
frequency. 0.4
Yes.
is the maximum frequency. You know.
At the very first step, you understood where is the peak of the density. Whichever was the peak, right? At least as far as empirical is concerned, this hypothetically assuming this is my peak, you basically went to that peak and then you find out or you found out corresponding x value, which is this position. Correct, everyone?
Yes, sir.
So
Yes.
if you again, if you see now, to find mode, there were two things what you require. First, find where my f of x is being maximized. Step number one. Step two is find the corresponding x. I'll repeat again. To calculate mode, two steps are required. Step number one, calculate where density is being maximized. Step number two, now go and find its corresponding x. When I say it's corresponding x, it means that this is the data point what I have. Now the x, respective x for this axis or this data point, which is this setting over here, right? Is that making sense, everyone? Guys?
Yes, sir.
Yes, sir.
Yes, sir.
Great. Now, can anyone help me? How do I exactly find, or before that, let me make things a little more simpler for you. I am creating a data frame using KD. When I write KD dollar, if you see, you have a lot of different variables inside it. So X obviously stands for your X axis. That is the value that the random variable takes. And when you write Y, obviously it's the Y axis, which represents the densities. So I am just saving them into the variable by giving them X and PDF, right? And now when I view the data frame, so the chart what you see on my screen on the right hand side, the black color line is kind of created using all of these data points, right? Can I say I want my PDF to be maximized? I can just come here, press the button, and if you see 0.39 is the one which is being maximized. Again, if you come to this chart also, you would appreciate that some number closer to zero point 0.4 is where my point gets maximized. Correct? So this is that maximum point where I'm being maximized. Question number one is answered. Question number two was, what is its corresponding x? It is nothing but 0.12 approximately, or 0.1199, however you want to see it. So my mode or my empirical mode is 0.1199. My theoretical mode is 0. Obviously, if you see, both the numbers are quite close by or nearby, so that's not a problem because it's an empirical information. They will never
That is
ever
a negative
match.
value of that minus point something will go. Minus point come no. Is a positive or negative? Because it is
See.
left to the negative.
No, so here looking at the chart, we assume that this point is the maximum point, right?
Yeah.
But
Yeah,
by
but
looking at
the
R,
mode is
it's this
slightly in
point
the
actually.
less than 0, no?
No. See, look, I drew the x-axis here, right? But when I go to R is telling me that this is not the mode. This is not the peak. This is the peak. And when you say this is the peak, and when you draw the line corresponding here, you
The
go on to the
positive.
positive side.
Positive.
Yeah. So since they by eye view looks exactly the same, when you actually see it numerically, the right hand side of the peak is the higher one. That's why when I sort it in an ascending order or a descending order, 0.3909 is the one which comes as the maximum point. You see all other values are less than that. So maybe we were looking at something of this number 389. Now obviously by eye, if you see 389 and 390 are kind of similar what an eye could capture. But numerically, it gets a lot more clear as to which is the peak, the left hand side or the right hand side of it. Guys, is this making sense? How did we calculate the mode over here?
Yes, sir.
Yes.
Great. Now, however, this is a shortcut method, right? I just kind of did a shortcut by, creating a data frame and seeing it visually. Obviously, if you're learning programming, you should know how to derive it using the information directly, right? So, yeah, tell me now, how exactly should I identify this 0.119969 using or writing down a program? So this was more what you just saw it in a pictorial or a eye view and you concluded it. But if I were to write a program such that now I can directly achieve this 0.1199, how would I do that? Again,
Maximum of y values.
fair. Okay. So he's right. For starters, yes. Firstly, just go and find what the maximum value of y is. In this example, it is 0.390. Okay. Now what? Now what?
Sir,
And the
when we
corresponding
are
x value.
calculating in the class mode, we are doing the second derivative test for the highest maximum point.
Correct.
So that
Here we
we
don't require derivatives, right? See, again, I hope you appreciate
Corresponding
derivatives and all
maximum
is
value of y, you gives x, no?
okay.
Maximum value.
I'll
Maximum value
just
of y
answer to
corresponding to x.
someone who was saying first. Sorry, Tom. I'll just clear that doubt first. So derivatives and all stuff is obviously when you are doing it in mathematics in classroom.
In
Here it's all
theoretical.
numerical play, right? Yeah, Tom. Sorry, I think I was saying something.
Maximum, you find the maximum y, and then corresponding to the value of y gives x mod.
But yeah, but how do I do that? So programmatically, how do I write that down? I don't know. Whoever was it, I hope someone was saying the double differentiation part. I hope that's clear. So
yes, sir.
here it's all numerics, right? You don't have to work with differentiation or stuff. It's all numerical part. So you just have to go and fetch the right number is what is important in a programming language.
Yes. No, you told na ki we have to write the program, so I thought that we
Correct. So program beyond derivatives, let's say. Derivatives is over. Right? I think so. When we had derivatives, we were too kind of overwhelmed when this derivatives will go. So now the derivatives have gone within our. We are not studying derivatives. Don't worry.
Then we can use a list maximum bracket maximum y.
Fair enough. So guys, what Tom said that you'll first have to find out maximum of y. If I slightly change his statement to say that instead of finding what is the maximum of y, find the position at which y is being maximized. See if that makes sense. So the difference is that when he says maximum of y, the answer is 0.3909. Versus when I say the position at which y is maximized, anyone, what is the answer? What is the position at which y is maximized? What is the answer for that?
267.
It is x.
Absolutely right. Very good. It is 267. Now, can I say if I know that my maximum y resides on 267, can I extract the respective x out of it?
Yes, sir.
How do I do that? How do I extract the respective x out of it?
We can just give the maximum of x position.
Nahi, nahi. So let's break it down. So if I just tell you I want to extract 267 of x, how do I do that?
List.
They use indexing.
List.
Yes, absolutely right. You use indexing. So you go data dollar x. Again, if you remember, why dollar? Because I want to go inside the data frame. So in the data frame, go to the x column, and within that, since you said extraction, or within that, absolutely I will use indexing and write down the number 267. Right? Once I run this one, if you see, I have the exact same number 1199695. Step number one, are we clear till here, everyone? This is how I will have to start to extract now. Yes, no? Guys?
Yes, sir.
Yes, sir.
Now this 267, sir, again you did cheating. You never found out it using any program. You saw it over here and then you plugged it the number here, right? Now let's try to write down a program or a line or a function which helps me get this 267, right? So when I say at what position this 0.39 is sitting, can I say it is a condition in a way that I want to try to find out the maximum of y and its corresponding position, everyone? Guys?
Yes, sir.
Yes, sir.
So we have a function in R called as which.max. What which.max answers is, which.max says you give me a set of numbers, okay, and I will give you the position where the maximum number resides. I'll repeat again. Which.max tells you that you give me a set of numbers, I will return you the position at which the maximum number resides. Don't get confused, guys. Which.max will not return you the maximum number. It will return you the position. Is that clear? It will return you 267. It will not return you 0.3909. If you want 0.3909, then which function you should use?
Extract. That extraction.
Okay.
Data
If we want,
data
guys, if we want a maximum of a set of value, which function do you use? In Excel, which function do you use?
Simply
maximum.
Absolutely. You use a simple maximum function or a simple use a max function, right? To get the maximum value. Here, my problem is not maximum value. Here, my problem is the position at which the maximum resides. The 267 is my question at hand, right? That gets answered using which.max. So when I write data dollar which.max, sorry, data dollar PDF, right? You see which.max gives you an answer of 267, where the max function gives you 0.3909. Is that making sense? The difference between which.max and max, everyone?
Yes,
Yeah,
yes,
we
sir.
have given the fx value and the position only.
Correct. Absolutely. You have the position in one and you have the f of x in another one. At this moment, for this problem statement, I require the position. I don't require the maximum value. Make sense, everyone?
Yes, sir.
Now see if you appreciate this, me doing this. I want to extract a x value at which my y is being maximized. So this combined, or this in a combined fashion, becomes my answer to calculate empirical mode. See if this makes sense. Line number 25.
Yes, yes.
Everyone else?
Yes, sir.
Great. So with this, can you guys make an attempt to this question now? So we learned what do you mean by empirical? We learned about kernel densities. We learned how to calculate kernel densities, and we learned how to calculate empirical mode using which.max and indexing. With all of these learnings now, can you go ahead and solve this question? Or can you make an attempt to solve this question? We still have 7 odd minutes left. Yeah. So, Ria, if you remember your part, whatever you wrote was absolutely right. You just have to change that mode function to these 2 to 3 steps what we learned now,
Okay.
right? So you just have to use the KD function to create the densities and start to get the maximum for each part. So this is the two line what you will have to change.
So I don't need to plot it.
No, plotting is not required. You just have to get the numerical answers. Plotting is not required.
We have answers.
Guys, are we clear? Yes, no.
Yes.
Great. Give it a try.
Sir, so here
Mhm.
the KD is equal to density of X. So X here is the R gamma.
Yes, yes, absolutely. X here is the R gamma. The sample that you will keep on generating at every step or at every iteration. I hope that makes sense. So I'll just mark the attendance in the meanwhile.
Sir, is there any way to find the theoretical distribution of empirical?
Theoretical distribution of empirical. What do you mean by that?
Means just we plotted here the graph in that way, just that this distribution is follow continuous or gamma, anything like.
No, no, I'm very sorry. I did not get your question again. So are you trying to tell me that how do I understand if my X follow if I have a random sample at hand, how do I find its distribution? Is that what you're trying to ask?
Yes, sir.
So let's say if I give you 10 numbers and now you want to know whether this 10 number follows normal distribution or exponential or gamma or chi-square. Is that the question you're trying to ask me?
Yes, yes.
Yes. So we do have that in our syllabus towards the end. So once we learn QQ plot, right, we actually will be able to understand if I have some exercise, how do I find out whether these exercise belongs to gamma distribution, chi-square distribution, exponential, log normal, normal, Weibull, Pareto, Burr. We will, use that technique to kind of compare and find it out.
And the goodness of it.
Yeah, absolutely. You can say goodness of it is one measure. Uh, Definitely, you can have that technique as well.
Sir, can I share my screen?
Yeah, yeah. No worries. I don't know. I think whoever was asking that question on distribution, I hope you're clear, right? We do have that. We'll be learning that using QQ plot and as Tom mentioned, using chi-square goodness of fit test to actually go and find out. So it's a combination of MLE and goodness of fit. What we will do once we are towards the very end of the semester.
Yes,
That
sir.
is where everything will start to overlap. Okay, okay. Thank you, Anushka. I think someone was saying to share the screen. Yeah, whoever was it, just feel free to share it off. I just quickly mark the attendance in the meanwhile. Bhavani is present, Hansraj is present, Rishitesh absent, Ashok absent, Kaustubh absent. Kaustubh, I think you have joined late.
Yes, sir.
Anyways, yeah, matlab, it's okay. Matlab, I am quite lenient in that. So I'm marking the attendance whoever I see the name at the moment. Okay, Kaustubh is there, Ria is there, Hernil is not there, Yash is not there. Anushka is there. Ali is there. Oth is not there. Ansh is not there. Abhar is not there. Tom is there. Ashish is not there. Yeah. Dikshita not there. Saumil not there. Anto not there. Fatima not there. Okay. Okay. So total of 7 students, if I get it right. 1, 2, 3, 4, 5, 6, 7. Yeah. All right. Great. Good to go. So done for the attendance, guys. Yeah, we can see what issue we have here. Okay, fair. So it's a fair doubt what she has put it up on the screen, everyone. This is what I wanted someone to go through. So if you see line number 50, what she has written, right? She have written KD dollar P, correct? Now, guys, one very important feature of the density function is that it doesn't matter what your variable name is, correct? KD, it will always be KD dollar X and KD dollar Y, right? That is how density function is built, that irrespective of what your variable name is, even if you name your variable as Tanish equals R gamma, density function will only see it as X, the random variable value, and Y, the density. It will not take Tanish and density or Tanish and Y as different variable name. It will only take X and Y, right? So on line number 50, what you have written KD dollar P, it will be changed to KD dollar X because density only uses two variable name irrespective of what you have named the variable. Yeah. Now if you run the program and if you execute mode, that should work for you. Yeah. I hope that makes sense for you.
Yes.
Okay, great then, guys. I think we have a lecture till 10:40 only, right? If I get the timetable right.
Yes, sir.
Great then, guys. Let's close here for the day. Once again, really sorry for the delay. Just so that this doesn't happen in future. If at all, I don't. So I have a habit that I always join meeting or my lecture 5 minutes prior to the time, right? If you guys have noticed till date, if at all the meeting doesn't start, to 5 minutes prior, right? Any one of you guys just feel free to directly call me. I think my number is there on the WhatsApp. So just feel free to directly give me a, don't do a WhatsApp call, just directly give me a proper telephonic call. In case something has been missed out on my part or there's some form of confusion, we don't waste on time. So just feel free to give me a call directly, right? Don't hesitate whether it's 6 a.m. in the morning or it's 3 a.m. in the morning. Just feel free to drop me a call. I think that's the best way so that we can save time in case I have missed or I have just
Can you share your number, WhatsApp number?
yeah, I'll also share it in the chat box rather. Yeah, I've done. All right, so all cool then. Let's stop it for the day, guys. Once again, very sorry for the delay. Right. Let's try to keep 2 to 3 pointers, right? If at all, I don't join 5 minutes prior, feel free to give me a call. Right. I think that would save us a lot of time altogether.
Thank you, sir.
Okay, then see you guys next week. Enjoy the remaining weekend. I think tomorrow is a holiday altogether. So actually, it's a weekend for you guys then.
Thank you, sir.
Okay. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you. Bye bye.